In section 7.4, we're going to be measuring angles. On page 458, look at your key concept over angles. The definition. An angle is formed by two rays with the same endpoint. Basically, the two rays are connected at an endpoint, which is the vertex, but that makes an angle. An angle can be named by its vertex, which is angle A, or a point on each ray and the vertex, with the point of the vertex having to be in the middle. So make sure you understand how you can name an angle. Look at the diagram in that key concept. You will see that you have, here I'll draw it. So here's the diagram that you see. I can say angle A. That's just the vertex. I can say a point on each ray, but the vertex has to be in the middle. So it'd be, you could say angle BAC or angle CAB. But notice the A is in the center because that is your vertex. The last way you can name an angle is by looking at a number. So you could call that angle 1. So then the second vocab word in this section is array. The rays are the sides of the angles. Now you already know what a ray is, but just know that the rays are the sides of the angle. The endpoint is the vertex. That is a vocab word. The vertex is the endpoint of an angle. At the bottom of page 458, it says when you name angles using 3 points, the vertex must go in the middle. The interior of an angle is the region containing all of the points between the two sides of the angle. The exterior of the angle is the region containing all of the points outside of the angle. Problem 1, let's start naming angles. In the got it problem, I have drawn the figure that you see in your book. What are two other names for angle KML? So if we're looking at KML, I'm going to highlight that in, I'm going to highlight it in yellow. So KML is this angle right here. It's important to notice that you cannot call this angle M. The reason why you cannot use the vertex in this problem is M could also be this angle here, or the whole angle. You don't know what it is. So if you can't determine which angle goes with the vertex because there's more than one, you can't name it by the vertex only. So KML. We could also say LMK. The other way we could name it is by saying angle 2. So those are the two other ways that we can name our angle. Part B. Would it be correct to name any of the angles angle M? Well, we just explained that. Angle M, you cannot measure it by angle M because you have more than one angle with the same vertex. That's why. You have more than one angle with the same vertex. At the bottom of page 459, it says, one way to measure the size of an angle is in degrees. To indicate the measure of an angle, we write a lowercase m in front of the angle symbol. In the diagram, the measure of angle A is equal to 62. In this book, you will be only working with degrees. So you'll notice that the example they give you is written like this. The measure, which is your lowercase m, of angle A equals 62. And by the way, your angle symbol is always the same. Your angle symbol is never going to be obtuse or right. The angle symbol will always be an acute angle. Your next vocab word is on the top of page 460. A circle is the set of all points in a plane that are the given distance, the same distance from a given point. A circle has 360 degrees. So 1 degree of a circle is 1 divided by 3/60 of a circle. A protractor forms half of a circle and measures from 0 degrees to 180 degrees. Here's your postulate. Consider ray OB and a point A on one side of ray OB. Every ray of the form ray OA can be paired 1 to 1 with a real number from 0 to 180. So then read the region in the gray. You can read it to yourself. I will just say, though, before you start reading it, just look at the picture. If you wanted to find the red region there of that angle, all you do is take the number on one of the rays, a number on the other way, and just subtract them. So all you do to find that is to subtract your C and D in that picture to get the measure of the angle. But you read that to yourself so you understand what you're looking at. Now, at the key concepts at the bottom of the page, you can look at that yourself. That's review from elementary school. An acute, a right, obtuse, and a straight angle. So just look at those as for review. At the top of page 461, we're going to measure and classify angles. We're going to skip the got it problem, but we are going to do practice A. So we're going to do problems 3, 4, and 5. All right, it says, use the diagram below. Find the measure of each angle, then classify the angle as acute, right, obtuse, or straight. So let's look at the number 3. Angle DAF. So angle DAF. So we look at it, and we can see that angle DAF, one ray is at 0 degrees, one ray is at 90 degrees, so we just subtract it, 90 minus 0, obviously that's a 90-degree angle. So we know that the measure of the angle is 90 degrees, and now we're going to classify it as a right angle. Number 4, angle BAC. Angle BAC, one ray is at 0 degrees, one ray is at, it looks like 25 degrees. Now, let's look at that. Obviously, you can see that the ray AB is also going through 180 and 155. You can still use those numbers and just subtract them to get the measure, but we know that's an acute angle. So we're using the smaller numbers. So 0 and 25, 25 minus 0 is 25 degrees. And we know it's less than 90, so it's an acute angle. Number 5 is angle DAE. DAE, we know it's acute, so we're going to use the smaller numbers. So ray AD goes through 90. Ray AE goes through 70, so we take 90 minus 70. That means it's going to be a 20-degree angle, and it's less than 90, so we have an acute angle. Page 461, right above problem 3 in the gray region. Let's read that together. Angles with the same measure are congruent angles. This means that the measure of angle A is equal to the measure of angle B. Once again, those are the measures of the angles that are equal. Then if we name the angles, angle A is congruent to angle B. You can also say that if angle A is congruent to angle B, then their measures are equal. You can mark angles with arcs to show that they are congruent. If there are more than one set of congruent angles, each set is marked with the same number of arcs. So make note of your diagram on how that looks and how they are labeled with the equal sign and the congruent sign. In problem 3, we're going to use congruent angles. We're going to do number 6 and number 7. I've already drawn the figure that you see in your book. In number 6, it says the measure of angle EFD, that's this angle right here, EFD, is 75 degrees. Find the measure of JAB. JAB is this angle right here. Because they have the same number of arcs, we know that they're congruent. So the measure of angle JAB is also equal to 75 degrees because they are congruent. Number 7. Number 7 says the measure of angle GHF, that's this angle right here, is 130 degrees. That's the one with 2 arcs. And then JBC JBC is right here. That's also 2 arcs. They're congruent, so we know that is also 130 degrees. So the measure of angle JBC is also 130. In the middle of page 462, we're going to talk about postulate 8. This is the angle addition postulate. It says, if point B is the interior of angle AOC, then the measure of angle AOB and the measure of angle BOC, if you add them together, will give you the entire angle, which is the measure of angle AOC. It's very, very similar to the segment addition postulate. Basically what it means is this. You have one angle that's cut into two other angles. If you add those 2 angles together, you get the big angle. That's what this postulate says. So let's look at the got it problem. The got it problem says the measure of angle DEF is a straight angle, or angle DEF is a straight angle. What are the measures of angle DEC and the measure of angle CEF? Well, we know that this is a straight angle. A straight angle is equal to 180 degrees. We know that these 2 angles, the one that represented by angle 11x minus 12 and 2x plus 10, they add up to that because it makes a straight angle. So we can just add them together. 11x minus 12 plus 2x plus 10, that would give us 13x, and negative 12 plus 10 is minus 2. So then you solve the equation. That would give us 13x equals 182. Divide both sides by 13, and you get the value of x, which is 14. Now we're not done. We got to plug them in to get the measures of those angles. So 11 times 14 is 154. And then we subtract 12. So that gives us the measure here of 142. CEF is 14 times 2. That'd be 28 plus 10, which is 38 degrees. And so your answers will be 142 degrees and 38 degrees. Does it make sense? Absolutely. This is an obtuse angle. This one is an acute angle, and those angles match. If you added them together, you would get 180 degrees, which is the straight angle. In review, the vocab that you should know from this section are these 4 words. An angle. An angle is formed by 2 rays joining together at a vertex, which is a common endpoint. The vertex is that common endpoint. Circle. A circle, a lot of people think, oh, it's just a round thing. A circle is a whole bunch of points, a set of all points in a plane that are a given distance from a given point. So that would mean, like, if I gave you circle A, that's the center. All the points around that are the same distance away from point A. And then congruent angles are just angles with the same measure.